Welcome to the Access Extension Framework Quick Start tutorial on the Control Center. So this tutorial is meant to be a quick once over. We'll drill down into the details of the functions in other tutorials. But the Control Center is a single form where we can access a lot of the functions of the extension framework, and we can manage a lot of the settings. So to open up the Control Center, you can either open it up directly from the form, or I find if often I'm in the middle of doing something else and I've got a whole bunch of things open, I like to hit Control G and then xf.cc will open the Control Center. Now the password is xf when it's released. You can change that in the Control Center itself, and it's not designed to be a high security password. The Control Center is just an access form, so somebody can go in there and circumvent the password if they want. Really what it is it's just a barrier so that a user doesn't stumble on it and start messing around with the framework settings. I'll go over the different categories of stuff that the Control Center stores. The first couple of pages are generally informational, so this is the front-end major and minor version, and this is the when we first set up the database, you'll remember that we created a GUID for the front end and an application ID and a few other things. This is all the information. When we want to release a front end version, we use this. If you want to use the GUI, this is one way of doing it. To bump up to version 7, for example. This is a list of all the different back-end databases. They're also listed elsewhere, but this is just an informational screen, so you can see it at a glance. You can see the version number of the back-end there, database type, the app ID, which is this thing here, and the long description, which is the equivalent of this, but for the back-end. The framework settings, we were saying a minute ago, you can change the password. Another option here is to hide all the framework objects. Now that's handy if there are quite a lot of objects in the framework. You can treat them like they're a built-in library, so if you want to hide them, then we go in here and you'll find that there's actually hardly any modules left. Let's show them again, and all the modules will come back. So it's kind of a good way of pretending that the framework doesn't exist. When the framework's hidden, it always does leave one module, this module XF base instance. That's visible no matter what. So that's just a handy little visual reminder that the framework is actually installed, even if it's not visible. But everything else should end up being invisible. It's leaving the Control Center as well. That's in case you actually want to click on that, but you can see all the subforms for the Control Center that were visible a second ago. They're all hidden, as are all of these other miscellaneous objects associated with the framework. So the second area is shared settings. This is things that are stored in the back end, so they're common to all of the front ends. This is the location for front end updates. So this is the magic folder where you drop a new front end update in and it will detect a later version and auto upgrade. There's also this facility that when the upgrade happens, it can copy files from a shared to a local folder. I've found quite often I end up using images, particularly when filling in forms and so forth. You want to use an image as the background for a report and then superimpose the form data on top of it. And seeing as Access really only plays nicely with bitmaps, you'll find an A4 size bitmap is actually quite large, usually somewhere around the 50 or 60 megabyte mark. And if you're loading them off a shared folder, that's quite slow. So there is a facility here where you can cache them to a local folder, and that will, every time you do an upgrade, it will check to see if the local file exists. If not, it'll copy it over. This here just sets a flag to say next time the front end starts up, do a table refresh. That's useful if you've been mucking around with some of the tables. You want to make sure that they're refreshed. So these are local settings. These are ones that are specific to the particular front end. What that means, so because these are central settings in the back-end database, they actually have to be updated on site, because when you issue an update, you're issuing a front end. These aren't going to be changed, whereas these settings here are actually going to be specific to the front end update you make. So you can change these and the next time you update, they'll be applied at the client's site. There's an option to do periodic auto compact. So rather than compacting every single time the database closes, which Access allows you to do, this will allow you to compact, say, every 14 days. The front end updates, there's a few settings here. This one here is the local file sync path, which is the partner for this shared file sync path. So it copies it from this shared location to the local one. These settings determine whether it attempts to automatically reopen the database after a front end update, or whether we just leave that to the customer to do that, to the client. And these MS Access options are some built-in Microsoft Access options that generally need to be tweaked, or people often like to tweak them in particular installations. So rather than having to go into every single front end and tweak them manually, we can set them here, and the framework will automatically overwrite them if they're different on startup. And there's an automated support message here. So this is something that'll be printed when there's an error and you're saying to the user you need to do something. Contact this address. So the next section is really to do with scripting. So the extension framework has augmented SQL built into it, which means basically it pre-processes. So it's able to generate and run SQL that's got quite a few extra features over what the built-in Access SQL has. So some of those features, for example, are that it allows you to control the properties of the columns. So normal SQL will allow you to create a column with a particular data type, column name and nullability. This will actually allow you to set up all those other things like the display control, whether it's a text field, drop-down box, Unicode compression. Any of these fields, let's go have a quick look. Let's go into design mode here. So any of these field properties can be scripted out in SQL. So this allows you complete control over your back-end database rather than just the fairly coarse-grained control of being able to set this information up here. So it'll handle all that. It's got the ability to do binary updates. So you can script stuff out as hexadecimal if it's, say, an image or a document. You've obviously got to be careful with this because when you script it as hex, it's character-based rather than binary and takes up probably 3 times to 4 times the amount of space that the actual binary data would. So if you have, for example, a 50 megabyte embedded document and you script it, that's going to probably end up being about 200 megabytes worth of script, which you may or may not want to deliver. So you do have to be very careful with this, but at the same time, if you're just updating something quite small, it saves what otherwise can be quite a hassle. So we can script insert statements. This is going to script all the data that's in that table and script up an insert statement to insert that into another back-end database somewhere. We can script an update. So let's see if we script an update here, and what's the primary key is body ID. So we can say let's update these 2 columns. That'll create the update statements for us, again, to go through each row in the table and update the values. And we obviously saw the schema, which is to actually create the table from scratch. You can see there's a few other enhancements here. Drop table country, so with if exists is another one of the enhancements in the framework SQL. That only drops the table if it exists, otherwise it ignores the command. And we've got another auto number fix here, is to fix a bug in auto numbering. So there's various little things like that that just make life a bit easier. And this script generator will generate the SQL that is compatible with the script interpreter that the framework uses to run the scripts. So this is where we generate the scripts. This is where we can edit them. We've got different scripts here now. This script is designated as against a particular backend and version, so this can be used as a backend update script to automatically upgrade the backend, but we don't have to specify a version. These can just be miscellaneous scripts to be run against anything. This is really just a sort of text editing area to store a bunch of scripts. And then when we come to execute the scripts, we've got the list of our scripts here. And we can choose different places. So the current database is this front end. An external access database can be any database we like. We just can browse to it. We've got 4 different options here for different connections to an ODBC database or OLEDB. So this will normally be SQL Server databases, and we need to fill in some details in the connect string. And then the final option is, we haven't covered the table linker yet, but the table linker allows us to link specific backends. It's a lot like the Access Link Table Manager. It'll allow us to define several backends and link them in. And the Execute Scripts window is smart enough to actually know what the backends are and automatically provide them. So this is the linked backend for our current database. If we've got more than one linked backend, then they'll all appear in this list. So that's a handy way of just running a script against the backend in a sort of ad hoc manner. Diagnostics is fairly simple to talk about, but the results can be quite complicated. So this is a schema brain dump. This is something I developed during my work with Access databases, because you're probably aware that when you get someone else's database, it's often in a pretty woeful state. So this brain dump sort of generates a whole bunch of information about the foreign key values, foreign key relationships, the different values that are actually, quite often referential integrity is not enforced. So for a foreign key, the values that are in the table might be different from the ones that are at the other end in the foreign key table. So this gives a pretty comprehensive analysis of the horrors that have gone on. Dump all modules to text. This was really just a way of dumping the module text, and I've used this a lot in the development of the framework, to a bunch of files in a particular folder. And I use WinMerge as a great text diffing tool, and it's great for once you've got these things in a text format, you can use tools to work out the differences between 2 sets of files, and there's a lot of different options there. This one's pretty simple, just dumps all of the object names in the database. So just creates a file with a list of names of all the objects in the database. This diagnostics area this is pretty handy. It's easy enough to search modules. So say if we're in a module, it's easy enough here to use Control F and search for something. So it's a bit more tricky if we're looking for something in a form. So say we'll have a look in here. And we've got some SQL. Let's have a look in SQL mode. So this is actually the text that's in that control. Say we want to search for something in there. Now that's a little bit more tricky. So we've got the row source property, and we've also got a record source property for the form, say for this form. And we've got control source properties as well, where we may have field names from the database. So just to go back to the control center here. So that's exactly what this does. We can search for a particular property, and that will search the control source, record source, and row source properties. For forms and reports, we can also search the text of SQL queries in the database. And optionally, we can show the values found. So if we tick this one, that will actually print the property values that it finds in this text window down here. We can also replace, so we can do a search and replace on a particular field or a particular function that's embedded in SQL in the forms. You'll notice there's a write crash log here. You're probably aware, if you've worked with Access for a while, that databases can become corrupted over time. Sometimes they're sort of passively corrupt, so they don't crash all the time, but when you do certain things, they start to get a bit unstable. So I've found, because this search and replace opens every single form and report in the database during its search, if something's going to crash, it'll usually crash while you're using this tool. So this crash log writes a text file to disk, which every time it opens a form, it will write the name of it first. So if something's crashing, you can refer to this crash log, and it'll tell you the latest thing that was opened before the disaster happened. Okay, so this is the last area here, the linker. The framework has a fully functional linker, so it will support linking to any number of backends. They can be Access backends, or they can be SQL Server backends, or any ODBC database at all. You can actually link to an Excel document if you really want to. Out of all the backends, there is what's designated as a primary backend. Obviously, in this case, we've only got one, so it's by default the primary. And that's where all the framework shared tables are stored. We've obviously got to designate some place for them, so that's where they live. So we may have more than one backend in here. For each backend, it's showing us, again, this information we put in when we set it up, a GUID. The app ID is sort of used as a little tag to check the type of database that we're connecting to. We've got these options: temporarily disable link management for that particular backend. This is for the scripting updates, so we can choose to apply update scripts to the backend automatically. So this says yes, enable. We want to do that for this backend, and this tells us what the latest version is. So when the startup function runs, it will check the backend to see if it's this version. If it's an earlier version, it will run update scripts to update it to version 4. And this is just the information about the backend file name, the path, and a bunch of different link behaviors that we can choose. So we can choose assigned, which means we basically assign it to a static location. Assigned with user select is the same thing, except if the link breaks and the database moved, or the most usual scenario with that is that the front end is actually moved and that it's no longer on the system it was before. Assigned with user select allows the user, it brings up a window saying, hey, we've lost the back end, can you find it for me please? And allows the user to select it. That there is actually a password protect on that as well, so we can put a password protect in so that the user can't relink the database without having first typed the password, which usually means they have to get us on the phone first. Link local simply means that the front end and back end live in the same folder, so if the links break, the front end should just look in the same folder that it's in, and it should find the back end there, and it can just automatically link. Follow is for if we have multiple backends. So for example, if we have 3 backends, they may, or they usually are, stored in the same location. So we may just choose the primary backend. We'll set up with assigned or assigned with user select, so we specify the path to that. And then the other 2 backends we may just set up to follow. So when we say follow, we specify the database, the backend that they're going to follow. So the second 2 we may set up to follow the primary. Obviously, it can't follow itself, which is why it's not displaying anything at the moment. The fallback aren't currently supported. These are ones I've used, but I haven't released them as part of the package yet. They're designed so that when you go, for example, if the database is installed on a laptop and you go off your network environment, it can detect that the network database no longer exists and just fall back to a local database on your drive. Equally, when you come back in from wherever you've gone and hook back up to the network, it can detect that you're back online and possibly run some scripts to update data back to the main database. But that's all a little bit more complicated. That'll be in a future release. So the linker tables, this is the list of databases that we've identified as backends. This is a list of all the tables. We've only got one backend, but in the case where you have multiple backends, they'll appear in this list, and you can designate that a particular table belongs to a particular backend. It treats views a little bit differently, so you need to tick this if the so-called table is actually a Microsoft SQL Server view. So here's your control over the relinking password. and we have the option to relink silently. Otherwise, it prints a message for you. There's a few tools here just to allow to make your life a bit easier. So, for example, if you've just installed the framework and you have a bunch of linked tables in your database already, first of all, you would detect your new databases here. So that will automatically check out what's already linked to your database, and it'll create back-end records for each back-end it finds. And then here, clicking this button here will identify all the tables for each back-end and add them to the table linker here. These are other just handy functions here. So force link refresh of this front end next startup. So this means the next time somebody starts it up, say at your client side, it'll automatically link refresh everything, all front ends. We can just decide to relink now. So that just relinked all the tables. Clear backend database paths ready for relink. So what that does is clear the paths in the case where we've decided to allocate a specific location to the database. It'll actually clear that path, and then again, we'd probably do that before we distribute it to a client, and then the first time they run it, it's going to come up and say, hey, I can't find the back end, can you find it for me? And finally, there's this button that removes the DBO prefix from all tables, which is what you get when you import from SQL Server. So that will just go through and clip that off the front, rather than you having to go through and edit every table in the database. A final feature here is the linker search paths. So if you do swap between several different environments, there's an option here to define specific places to look for a backend database. So again, recall that we can allow the user to attempt to find the database. What we can do is put some of the search paths. We can put the expected location of the backends in as a search path, and then when it brings up the window to ask the user to select, it will automatically identify anything that it's found in the search path, and instead of having to type something in or browse to it, they can just click on that and say, this is the one. So we've got two different ones here. This is a local list of search paths which lives in the front end, and again, that'll be overwritten when we deploy a new front end to a client site. And this is one that lives in the back end, so that will be shared, and that won't change when we deploy new front ends. So there's one final tab that's been added since we did most of the tutorial, and that's the error log tab. The framework has an error handler. It uses that internally, and we'd encourage you to use that for your own code as well. And part of the error handling process is that it logs the errors to a shared error log table on the back end, on the primary back end. It's also got a facility if the error occurs when the back end is not linked, then it logs the error to a local error log table in the front end. And as part of the framework startup procedure, as soon as the back end becomes available, it will then copy that information from the front end table to the back end and delete it from the front end. So here you can see the contents. This list contains the contents of the back-end error log table. The columns that are long and that tend to have a lot of information in them are, if you select the row, they'll be printed out down the bottom here. They're selectable as well, so you can see what's going on. I'll just quickly go over the columns. So the ID column is just the auto number for that table. The session ID is useful if you've got several different devices or front ends hooking to the back end, and you can use that. I think it just defaults to 0 at the moment, but you can actually pass a session ID into the error handler if you wish, and that allows you to sort of keep a thread of which errors are coming from which front end, which is kind of useful. Otherwise you just get them all in time sequence with no indication of which error came from which place. So if you're trying to basically get a thread of errors, the session ID can be very useful. The application name is simply the application ID of the front end. It's part of that information we enter when we import the framework. And the error category is fairly self-explanatory. It's either log. Here is the link table manager. Every time the link table manager checks the tables, it logs to the error log. We've got some Jet backend upgrade scripts here that are marked Jet. And if we scroll down a bit, we've got some actual errors that have occurred while we're doing development. So we can do a bit of filtering here. We can filter by date. We can hit today only. We haven't had any errors today. Clear filters, and we can also filter by keyword. That just works in the error text column at the moment. So For example, if we want to have a look at the script commands, we can type in command. So this tab just makes it easy to list and filter those errors when you're looking for what went wrong. So let's just have a quick look at the error logging process in the back end. So there's this global function called process error that the framework provides. That just takes the normal error object, error number and description. So this is just a string that it logs the error location, and that in this case is logging the name of the form and the name of the function that the error occurred in. And there's a whole bunch of other parameters we can use. There's the error type, there's the additional information. Log only indicates that we don't want to display the error, we want to log it to the back end. So that basically prevents a user message from being displayed, but in all other ways it runs the function normally. And we can have a quick look at what goes on behind the scenes here. There's a bit of a redirection, and you can see here's all the parameters we pass in, and it makes sure application echo is turned on, it turns off the hourglass if it's on, echoes an error to the user, prints the error to the debug window, then it gets the front-end application ID and logs the values to the table. So if there was an error logging to the back-end tables, then it will try to log to the local error log. So these are other global variables within the framework that cache the last logged error. So if the error handling code produces errors itself, then it may reset the error object to a different error from the one that originally caused the problem. So this is a handy way of just caching that information. And that pretty much wraps up the overview of the control center.